Okay, to finish the proof number 30 from the geometry homework in section 5.1, it says to use the diagram shown. I've copied the diagram here, and give it information to complete the proof. And it's given that line segment GJ is the perpendicular bisector of line segment HK. And it has it marked accordingly. Here we have our right angle. We know that J has to be the midpoint because HJ is marked congruent to JK. However, those are not part of the triangles that we're proving congruent. We are proving the triangle G, it's supposed to be a different color, triangle GHM is congruent to triangle GKM. Okay, now hopefully you see in the overlapping of colors that line segment GM is going to be, or has to be, congruent to line segment GM by the reflexive property. Now keep in mind, triangle congruence, in this case, because these two particular triangles that we're proving congruent are not right triangles, we have to have three congruence statements. So our first congruence statement is that line segment GM is congruent to line segment GM by the reflexive property. Okay, and again, if you look here, G to M, those do match up in corresponding orders, so those segments are in fact the same, so they do have to be congruent. Now, in addition to that, we have this definition of perpendicular bisector. Okay, now the definition doesn't help us because down here we see that it's marked that those parts are not part of the triangles we're trying to prove congruent. However, the theorem that bears its name does. Now, the perpendicular bisector theorem says that any point on the perpendicular bisector is equidistant from the endpoint of the segment that is being cut in half. The segment HK is being cut in half. Okay? So M, which is on the perpendicular bisector, has to be equidistant to H as it is to K. Let's put two congruent marks here so it's not confused to be congruent with that one. So we have another side congruent statement, or we have it marked. We need to make sure that we get it into our proof. So we can say that line segment MH is congruent to line segment MK, and that's by the perpendicular bisector theorem. Okay? Not only is M on the perpendicular bisector, so is G. Therefore, G is equidistant from H and K. So we have at least another side marked as congruent. That congruency statement would have to be that line segment GH is congruent to line segment GK by the same reason, perpendicular bisector theorem. And therefore we have three side congruence statements to three sides of each of these triangles. Therefore the triangles are congruent by the side congruence postulate, and that's how you finish the proof for question 30 from the geometry text 5.1.